2.5 Admins, episode 145. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary Clara article plug is OpenZFS for HPC clusters.
Yeah, so ZFS backs some of the biggest high-performance computing systems in the world. Oak Ridge National Labs just recently launched their Orion system, which is something like 47,000 hard drives, 4,800 NVMEs, and another 500 NVMEs for metadata to make a 700 petabyte pool out of ZFS. And we talk a bit about why ZFS is the right answer for these kind of giant workloads.
Right, well, link in the show notes as usual. Windows 11 is so broken that even Microsoft can't fix it. This is a TechRadar article.
And like many TechRadar articles, it should probably be taken with a bit of a grain of salt. That's certainly not untrue. Yeah, there is a particular bug that has been floating around right now that Microsoft engineers are basically giving up on. If you've experienced it, they're like, you know what? Nah, if this happened to you, your registry is basically screwed and you really need to just kind of wipe and reload. Now, this is a black eye in the sense that some Microsoft engineers have said this publicly enough that a site like TechRadar picked up on it and published it. But the reality is there have always been any number of ways to break Windows badly enough that nobody, all the way up to and including paid support at Microsoft, is really going to resurrect it. And I'm going to be honest here, a lot of the reason that I wanted us to cover this was literally just to bring up the fact that, yes, Windows is this incredibly baroque and full of cruft that there are lots of well-known conditions under which you just go, Nah, this is trashed. We got to start over from scratch.
Because if you took a Linux or FreeBSD system, you could break it to the point where you couldn't boot it. It just wouldn't work at all. But you'd be able to fix it if you knew enough about what you were doing.
Perhaps even more to your point, Joe, and it is a very great point because for decades, people have done exactly that. They have broken their Linux and FreeBSD installations so incredibly badly that they wouldn't even boot. And then they've gone online on a different computer and found some random other person on the internet to say, oh my God, this happened and how do I fix it? And this completely unpaid rando who is not doing a job for anybody is able to walk the clueless original user through the process to do anything from repair a boot sector to, fix broken package manifests, any number of ways to just incredibly badly screw up a system. And odds are real good some rando on the internet will help you fix it. And it's not because randos on the internet are better at this stuff than Microsoft engineers are. It's because there has been a lot more impetus to clean up the code as we move along in the open source world and to make a better product because we have to look at it and other people have to look at what we did and we have to live with ourselves. And in the commercial domain, there's a lot more impetus to say, no, we want backwards compatibility forever. Even if you don't want to bring up the idea of whether you want to spend developer hours on improving things that aren't immediately visible in a product, which is a big problem in closed source commercial software, even if you hand wave that away, like I said, the motivation of the money folks to be like, you know what, we might miss $1 if we can no longer run this program from 1983 the way that it was compiled in 1983. In the open source world, you're more likely to say, let's give those folks a path forward, but this is ridiculous. We need to deprecate that.
A lot of it comes down to the registry in Windows is a database, and databases don't handle unexpected shutdowns and damage well. Now, maybe they could implement some kind of copy on write mechanism just for the registry. Like, I'm not even saying replace the file system, just have snapshots of the registry with volume shadow copy or something to make this a little less.
Is your solution really just ZFS for Windows, Alan?
No, I'm talking about what they could do in Windows with NTFS. It's using some of the same concepts you have instead of it, but I'm not talking about replacing the file system. I'm literally just saying...
Yeah. But still, your solution is still basically ZFS.
Or even just to treat the registry like a database proper. So have a write-ahead log or something.
Hang on a second. I got to come to my boy's defense here. I got to come to Alan's defense for once. Alan is not saying the solution is ZFS. Alan is saying the solution is a bunch of well-known industry standards that are exactly how you address this kind of problem. Atomic snapshots, the ability to roll back, the ability to replicate, all these kind of things. They're not ZFS specific. None of those things are ZFS specific. ZFS just happens to be one of the best implementations available for that set of tools.
Yeah, and I'm not saying do it for the whole file system. I'm just like the registry is an important thing in Windows and it doesn't boot if it doesn't work. So how about we keep the last couple of copies of it around or something? It's not that big where the copy and write penalty would hurt you as much as like trying to do this with giant files on a file system that doesn't actually do copy and write properly.
That's actually what system restore points are supposed to do, among other things.
Mm-hmm.
The larger problem is that when you talk about the registry being a database and databases get corrupt, and what it really sounds like you're saying there is you're talking about like, crash corruption. And that's not a problem that I've really experienced hardly at all with Windows registries. When they get corrupt, in my experience, it's not corrupt in the database sense of the word. It's corrupt in the application level sense of the word because somebody's installer did something incredibly stupid, or some end user trying to work around a problem did something incredibly stupid manually, or a very experienced person like myself went in the registry and did something very stupid manually. Like, these are all very common failure modes for the registry. I don't think that crash corruption is really the issue. And when you understand that the issue is installers doing things that they shouldn't do, now you're left talking about, well, we have the problem of how do we make sure that we take the snapshots we need to take when we need to take them, and in a way that you can tell which one you need to go back to. Because your system just kind of makes system restore points when it wants to, or when an installer tells it to. And if somebody wrote an installer that nukes your registry, what are the odds that they decided to actually put in the system restore point first? And then on top of all that, the system restore points aren't going to say, well, this is the system restore point before you installed Chinese malware desk.exe. There's going to be a date and a time, maybe sometime recent, maybe it won't, maybe it'll fix your issue, maybe it won't. They're also not very reliable in my experience.
And it does seem to be, according to the Microsoft posts on this, the Start menu, Windows Search, and Universal Windows Platform apps might not work as expected or might have issues even opening because of damaged registry keys or data which might affect apps that use the Microsoft Office APIs to integrate with Windows, Microsoft Office, or Microsoft Outlook or Outlook Calendar.
I actually took delivery of a refurbished laptop last week that was suffering from this bug right out of the box, right from their system image. Exactly what they're talking about. The start menu did not display properly. You just got a big old blank, empty frame with nothing in it.
It definitely seems like they could have a better fallback when the registry isn't working, and maybe the start menu could still work. Because, as far as I know, the start menu is still basically a bunch of directories composited together with their shortcut files. It's not magic.
Now, the interesting thing in this particular case was that I actually was able to recover that laptop without doing a complete skunk and reload. What I did on that one is I did the factory reset option, which, you still lose all your stuff, but particularly for normal users, it is a lot less scary to go, start and search in settings and find reset until it reset my PC than to say, okay, I need to go find a USB drive with a Windows 10 ISO on it and boot from it.
For one of the known apps that causes this issue, something called ClickShare, apparently just uninstalling the app is enough to get your start menu to work again.
But how do you get to add and remove programs with no start menu?
You press Control-Alt-Delete, and you run Task Manager, and Task Manager will let you spawn a console.
Yeah, or Windows R, I think, still gives you the run dialog without going through the start menu.
Negative, Ghostwriter. Negative R pops up the start menu with the search box in it. That's actually where that goes to now.
Okay, and 10, it still does the right thing. But yeah, I guess Task Manager, and then know the right MSC file to get the control panel item you're looking for.
But that backwards compatibility thing, I have got audio tools from 15, maybe even nearly 20 years ago that run reasonably well on Windows 11. And there's a lot to be said for that. But I suppose there are some trade-offs, and this is potentially one of the trade-offs that we're looking at.
There are better ways to do it as well. You can run FreeBSD 4 apps on FreeBSD 14. You just install a package that provides the compatible libraries and have a kernel with that option enabled, and you can still run the old binaries from 20 years ago.
You could also not amass so much technical debt yourself in the first place and say, hey, this application is getting incredibly stale and I should be looking for a path forward to something that's still maintained.
Or, if it's a C program, you can probably just compile it to work on the new version.
Okay, this episode is sponsored by the Traceroute Podcast. Find it on Apple, Spotify, or wherever you get your podcasts. Season 2 features new co-hosts and new stories about the inner workings of our digital world. Each episode of the Traceroute Podcast will peel back layers of the stack to find the stories about hardware's very real effect on human lives. The second episode of Season 2 covers the most important question of our future. How do we prepare kids for jobs that don't exist? Studies show that because of the rapid progression of technology, up to 85% of jobs that will be available in 2040 haven't been created yet. It's a vital concept to address now, and one of the many they're covering on the new season of the Traceroute Podcast. What I like about the Traceroute Podcast is the focus on individual people's stories and how changes in tech affect them. So listen and subscribe to the new season of the Traceroute Podcast on Apple, Spotify, or wherever you get your podcasts. Just search for the Traceroute Podcast. You know M.2 SSDs suck, right?
Yes, I do.
This is an article on PCGamer.com, and I didn't know that they sucked until I read this, I must admit.
If I recall correctly, I was the one that dumped this into the show doc originally. I came across it in my Google News feed, and when I saw the title, I was just overjoyed. Finally, somebody else gets it. And I got to tell you, I don't normally submit links into the show doc from PC Gamer, but yeah, dude nails it. Everybody gets real excited about consumer NVMe SSDs, the M2 format. They don't necessarily care that much about the format. They get very excited about the rated speeds. NVMe is a very promising protocol. Please don't get me wrong about that one. It opens up a ton of possibilities for interacting with storage in a more modern way that makes a lot more sense with massively parallel solid-state media, which if you don't realize, even just a cheap SATA SSD, it's really kind of not like one drive. It's effectively a RAID array in a little tiny box. You just see it as a single drive. A lot of the speed comes from the fact that individual media stripes can be and are accessed in parallel, and a lot of the reason that you tend to see much slower access patterns with some of the same workflows that challenge Rust drives with mechanical seeks. Obviously, there's no mechanical seek on an SSD. It doesn't care about that. But if you're accessing teeny tiny bits of data in ways that force it to only be able to read from one bit of physical media at a time rather than across multiple banks at once, well, you get a lot less throughput. So NVMe offers developers a much better way to issue massively parallel requests to fast drives, and that's a good thing. NVMe also gives you a more direct pathway between the CPU and the storage, which is also a good thing, particularly when you're talking about modern, incredibly fast solid-state storage. But M.2 is awful. It's directly on the motherboard. It's very frequently shrouded by, great big hot honking GPUs. You end up having to take apart your whole freaking computer just to swap one out. You can't hot swap it because you've basically just jammed a thing directly into the brain of your computer. And if you yank it, it will react a lot as though you yanked, a stick of RAM out of it while it was running, which I had a client one time who thought that was perfectly fine and swore that her voicemail server kept running for 2 days after she did it. But spoiler, no, it didn't. So that leaves us with M.2. It gives us access to NVMe capable media, which is great, but it is just the most god-awful physical format I can imagine. If you would like a comparison to why this is a bad idea, imagine that the only way you could plug electrical appliances into your wall was directly like wall warts. You cannot have a power cord.
Yeah, some of the biggest problems are heat, the fact that they get really hot, they're really small, and sometimes they have a heat sink or you have to add one and it doesn't come with one. And it often means that advertised speed they say on there, you get throttled to a lot less than that because, I got too hot, so now I have to work slower. I actually saw this in production for a customer just 2 weeks ago, where they had a pair of these M2 drives on a card in a Dell server, and they got up to about 75 degrees, and instead of slowing down, they just got write errors or completely fell off the bus and caused the VDEV in ZFS to fail. And so then they had to let it cool off, get it back in, and then the resilver trying to catch it up was getting it too hot again. And it's we're going to have to fix the fan and put heat sinks on those. Otherwise, these drives that are holding the OS for the server and are not that busy are just going to keep falling over. Imagine if it was, the ones trying to run the database.
For the first roughly 2 years that Dell started putting M.2 drives in its Alienware and Precision mobile workstation laptops. I actually ended up just preemptively buying SATA solid-state drives and putting them in those laptops straight from the factory, because in the first 6 months that those laptops were out and non-optional, I had one laptop burn out 3 of them in a row, from Dell. And after the third one, my client was like, okay, this sucks. I don't want to deal with Dell's warranty anymore. I want you to fix it and I'll pay you. And rather than me dealing with Dell's warranty people, I just, went out and got one of my standard SATA SSDs and put it in the laptop, and it never had a problem again. Then that happened with another client on another Precision mobile workstation laptop. And after that, I was just like, okay, no, this is not what we're doing. And I guess for a while, I'm just committing myself to preemptively buying SSDs that won't burn out and doing brand new Windows installations on them with every laptop I buy.
But this was an enterprise Dell server having the same problem. There's a reason these are called gum sticks, because they're just going to get thrown in the garbage and then stepped on.
Mm-hmm.
And then they also note that, especially as we're getting at PCIe 4 and 5, the routing for these to put them in weird places on the motherboard, like between the PCIe slots, is getting worse. And it's wasting a bunch of PCB space, and it's very fiddly to install. And like you said, they're not hot swappable. So the PC Gamer author is like, we solved all these problems. It's called U.2, and it looks like one of those 2.5-inch hot swappable SSDs, but it's actually NVMe interfaced. And it's like, why are computers not built with this?
Mm-hmm.
Even in your home machine or your laptop, it's like, it'd be really nice to actually have a thing with enough heat dissipation built into it, and B, that looked like the form factor we're used to. Like, maybe in some laptops, the ultra-thin smallness of a M2 is useful, but in most of my computers, I'd prefer something that looked like a U2 anyway, especially if I'm going with server hardware. The drives have to be hot swappable. None of this, it's screwed into the motherboard with a tiny screw, and you're just screwed if it dies.
And I can confirm that U.2 is a perfectly lovely form factor. I've got a U.2 drive in my test bench rig over there right now, and it doesn't add much in the way of cost. I don't see how it possibly could, because in order to test that U.2 drive, I had to buy a PCIe card for it to put into my test rig, and the whole freaking card cost me like $10 just buying one of them and, putting it in a machine. So I can't imagine that just building U.2 interfaces into computers would really add any cost.
Yeah, I think it'd be fine. The other important thing the article notes is U2 drives use 12-volt power, whereas M2s use 3.3-volt power. So the power going to the hard drive is better as well.
Yeah, especially if you're going to standardize on a completely 12-volt system.
Right. Intel is trying to do with the release of the ATX 12VO standard. It just hasn't quite caught on yet.
Okay, this episode is sponsored by Factor. Now that it's summer, you might be looking for wholesome, convenient meals for sunny, active days. Factor can help you fuel up fast with flavorful and nutritious ready-to-eat meals delivered straight to your door. You'll save time, eat well, and stay on track reaching your goals. With Factor, skip the trip to the grocery store and skip the chopping, preparing, and cleaning up too, while still getting the flavor and nutritional quality you need. Factor's fresh, never frozen meals are ready in just 2 minutes, so all you have to do is heat them up and enjoy. Looking for calorie-conscious options this summer? Try delicious dietitian-approved calorie smart meals with around or less than 550 calories per serving. Jim tried Factor and said the meals were quick and easy to prepare and liked that there was plenty of variety. So go to factormeals.com/25A50 and use code 25A50 to get 50% off your first box. That's code 25A50 at factormeals.com/25A50 to get 50% off your first box. Why 2.4 gigahertz Wi-Fi is both the savior and the scourge of the smart home.
It's the savior of the smart home because it's got excellent range and penetration. And it's the scourge of the smart home because it's got excellent range and penetration.
And because everything uses it.
So the issue here is that, the everything uses it part, I'm not going to buy that as the problem because your everything is pretty much always going to use one thing, and moving it all from 2.4 to 5 doesn't help a lot with that. It maybe gets you away from the microwave noise to some degree, but even there, microwaves are filthy, cursed objects and tend to throw off birdies and harmonics that will tend to interrupt 5 gigahertz as well, although not as badly. The big issue, no, is what it always is. It's airtime. And a smart home, it wouldn't be a smart home if you didn't have a ton of gadgets that all wanted to be wirelessly connected and all expected to be able to reach control and sensors whenever they wanted to. And the more things that you've got on the same Wi-Fi band, the less airtime you have available. And it gets even worse when you're talking about long-range connections. The whole 2.4 is the savior of smart homes. Again, usually people say that because they're applauding the excellent range and penetration. You can put one 2.4 gigahertz router in, and you can walk all the way over to the other side of your house and go, oh, look, mini bars is good. But it's not good. It's actually still a pretty terrible connection. And, that connection from all the way at the other end of your house to the 2.4 gigahertz router all the way on the other end, it's going to be happening at a considerably lower bit rate. And you're not going to transfer less data because you have a lower bit rate. You're just going to take longer to do it. And for the entire time that you're transmitting, everything else in the house has to shut up. So when you've got one super long range 2.4 on one single band in your house, I hope it's not too smart because, again, the more devices you pack onto it, the worse everything's going to get.
Yeah. And, if you live in an apartment building, your neighbors matter a lot more because that penetration doesn't stop at the edge of your house. And I just remember experiments I did when I was like 12, comparing a 900 megahertz to a 2.4 gigahertz cordless phone and how much further away you could still make phone calls from your house. It's like I can go all the way back the end of our backyard and halfway into the neighbor's yard before I start getting static on the phone connection on the 900 megahertz, and the 2.4 wouldn't go as far.
That's not the reason for that, Alan. It's a lower frequency, longer wavelength, longer range and penetration, which is both the good thing and the bad thing.
Yeah.
As a lot of people found out when everybody made the same discovery you did, look how far away I can get from my house with my phone. And they all go out and buy 2.4 gigahertz cordless phones. And now everybody's cordless phone experience sucks because they're all trying to talk over one another with essentially, worse yet, analog devices with no actual protocol to make them even try to get along with one another.
Yeah, because the biggest concern is airtime, what you really want for your smart home is to make sure your devices aren't being unnecessarily chatty. If they don't have anything useful to say, why are they constantly saying, no, I'm still here? There's a lot that can be done to make them only talk when they have something interesting to say, and that would save a lot more than going to a different frequency.
Well, and another thing that the article brings up is the fact that a lot of things can actually be connected via Ethernet, which just takes them out of the equation completely. Like a lot of TVs and stuff, but people just assume that Wi-Fi is just the way to connect stuff.
Yeah, that's correct. Anything that you can connect over a wire, you absolutely should, basically for every conceivable reason. Higher performance, lower impact on your other devices, better security. The reasons to use the wire are legion. Basically, unless something needs to be wireless, it really should not be wireless. That brings us to another point, though. It's probably not realistic to expect most people who are super enthusiastic about smart home devices to have any real control over how noisy those devices are or aren't. I mean, they're going to do what they're going to do. You generally aren't given a whole lot of control over it as their user. What you can do, however, is you can break things up into multiple collision domains. So instead of having a single router in your house, you can get a mesh system or a set of wired access points. Obviously, wired access points are the best, but even just simple consumer mesh makes an incredible difference as to how many devices you can have active and still have a good network experience. The other thing about that is a lot of people don't realize if you've got a consumer mesh system and your mesh nodes have their own wired Ethernet jacks on there, you might not think there would be a big difference between, say, letting your PlayStation connect wirelessly directly to your main node, your router node, or, having it connect to a satellite node wirelessly that's right there in the room with it, or plugging a wire into that satellite. But there is actually a very big difference. If at all possible, even if you've got a wireless backhaul mesh network like an Eero or a Plume or Netgear Orbi or what have you, you're much better off if you can plug things into the satellites, because what happens is the satellite node will actually aggregate all of the data that multiple devices want to upload and be able to organize it all into a coherent stream that will utilize less airtime, and they'll be able to work better with one another than if they were all making individual Wi-Fi connections. Now, if that's not making sense to you yet, let me point out what happens when devices actually do collide, meaning two different devices both try to transmit at once. One, the receiver can't make heads or tails of it, so they both have to try again. Two, they have no out-of-band communication with one another, so the way that they get around that is by each backing off a random amount of time and hoping they didn't both pick the same random amount. So whoever got the smaller random sleep interval transmits first and wins, because now the other one didn't hear them and so doesn't stomp over them and waits for them to finish. Now, on the other hand, if you have both of these devices simultaneously trying to upload data over the cable to your satellite node, which itself has a Wi-Fi backhaul, now what happens is it receives both of those transmissions in real time without any problem, and it seamlessly puts them together in one stream to go over the Wi-Fi. You never have this back off and retry nonsense, which makes a big difference when you're talking about moving a lot of data from multiple things all plugged in.
It ends up using up more airtime, right? The first time when they both tried to talk, all that airtime is wasted now because it all got garbled. And then they're backing off and then both have to retransmit. So you've used at least 3 times instead of 1x the airtime. And then if it's wireless and then repeated via the wireless, we then have to receive it all and then actually spend the airtime to transmit it to the main node. And so, yeah, you've used something like 4x the total airtime versus if you can wire it and then Wi-Fi it, then it's only 1x the airtime.
Yeah, and to be clear, you've introduced latency issues into both those devices directly because they had to back off and retry and wait and try to figure it out inefficiently. And you've screwed up the environment for the rest of the devices on your network entirely because of the additional wasted airtime that Alan was talking about.
Yeah, if everybody's in a good rhythm of taking their turn to talk and then 2 people talk at once and have to back off, then you've messed up the whole cadence. And your applications could be very sensitive to that, right? If you're doing a live video call, if your packet gets delayed by a bunch, then that's when you get that hitch in your video or the buffering on your Netflix stream or whatever it might be.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Okay, Corey writes, I switched to ZFS last year and love the Sunoid and Syncoid scripts for managing all my snapshots and backups. I was considering doubling down on my dependence on ZFS and using the built-in encryption rather than LUKS for some of my more personal datasets. I did encounter some open issues on ZFS encryption. What are your opinions on the reliability of ZFS encryption? Are there other ZFS ghosts to be aware of?
There are still a couple of collywobbles to get worked out in terms of ZFS encryption. I do think that it's reliable enough for use, but in particular, if you're wanting to use the raw send option for ZFS replication that replicates encrypted data sets as they are on the metal, never breaks the encryption. I've seen enough people run into some weird little edge cases with that I think my advice is definitely not don't use it, but it is maybe keep an extra close eye on it. As with any other encryption product, just remember, the function of it is to make your data unusable to anybody who doesn't have the key, which means it's a pretty shallow bug for it to end up being unusable to somebody with the key as well. So be careful, keep an eye on your backups, make sure everything's going the way it is, and be prepared to dive in and give things a hand if you need to.
As much as it's very inconvenient, the fact that it fails closed and that your data stays protected instead of falling open is what you want it to do. Is just you want to be careful and make sure you have backups, and that, like Jim said, that you're keeping an eye on things and watching out for signs of problems. I
would imagine that quite a few of your customers at Clara want to use ZFS encryption, so that must be something that you and your team work on then.
Yeah, we're actually investigating a specific set of bugs around encryption and helping other clients implement encryption. One interesting thing we've noticed is that none of the encryption bug reports have come from FreeBSD. And it's not clear where the difference is that's causing that to be the case. If it's just that there's maybe a bit less uptake there because people doing it on FreeBSD are less likely to opt into encryption, or if there's some implementation specific thing around it that's triggering the problem. There's not that much code that's different between the two, but there is some. And so far, we've not been able to recreate the problems that people have readily enough because, as soon as we can make the encryption problems happen on demand, we can probably fix them. But when it's just these slightly scattered reports with not a lot of detail, and obviously people that are encrypting the data can't readily let us see what was happening on the insides of ZFS at the time, it makes it harder to investigate these problems. But Clara does work on these specifically for our customers.
I hadn't even thought of that, but yeah, that must be a problem because if you're encrypting your data, then you are necessarily private about it and going to be less likely to kind of give up all the information you need for the bug report.
Yeah. And even just in general, leery about giving us even just unredacted logs, let alone a crash dump that has kernel memory contents and so on.
But you're saying that it's fine on FreeBSD and everyone should just use that.
I'm not actually saying that, but I'm saying we've not managed to see any crash reports from there where the debugging tools would make it easier to figure out what was going on.
All right, so FreeBSD is better for finding the cause of the bugs then, right? Okay.
In some cases. Linux has a better facility for finding out why things hang, but FreeBSD has better facilities for finding out why things crash.
Yeah, I must say when my Linux systems have crashed, that's where the logs end. And often the logs end before I even realized it had crashed, certainly on the desktop.
But if you are hitting one of these issues, definitely get in touch with us and we'd love to help figure it out.
Yeah, I bet you would. Cha-ching. Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joerest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Alan Jude.
We'll see you next week.